Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. I am discussing the topic, the chapter Differential Equation, and the subtopic of Differential Equation is non-exact differential equation. In last videos, we have discussed several methods depend on non-exact differential equation. So now here remaining methods we are discussing on non-exact differential equation. So here first we will discuss remaining only two methods based on a non-exact differential equation. Method 5 I have discussed in last videos. 4 methods I have completed, but now we want to discuss last 2 methods, remaining 2 methods. So now methods 5. In methods 5, if a given differential equation is a homogeneous, in method 5 we are considering only homogeneous differential equation. And a homogeneous differential equation always be a not exact differential equation. Every homogeneous differential equation is not an exact differential equation. So we showing here how a homogeneous differential equation always be a non-exact. So here this one question is given here. So first of all, we are showing that this differential equation is homogeneous. So what is definition of homogeneous? We have already discussed what is homogeneous differential equation in separate homogeneous chapter. But here we are discussing non-exact differential equation. Those differential equations which are non-exact differential equation we are discussing here. So homogeneous differential equation is also a non-exact differential equation. So here any type of homogeneous differential equation, we check out that this is a non-exact differential equation. So here one question is given us, x cube plus y cube and dx minus xy square dy is equal to 0. This is homogeneous differential equation. How we can say that this is homogeneous differential equation? The definition of a homogeneous differential equation is, in each term of a differential equation, the total degree of the variable in a term are equal, is known as a homogeneous differential equation. In each term of, I am repeating again the definition of a homogeneous differential equation. In each term, okay, there are terms are given in a differential equation. So in each term, the total degree of the variables in each term are equal is known as a homogeneous differential equation. So here we check. This is the first term of differential equation. First. So in first term, the degree of x, here is only x variable. So the degree of x is 3 here. Now plus sign plus. Next term is y. So degree of y is 3. There is single variable. So y is 3. So here total degree of this term is 3. Here is addition. So addition separate term x cube plus y cube. So the separate term have 3 degree variable. And dx minus xy square. Here is multiply xy square. Between x and y square there is multiplication. So x degree has 1 degree and y square has 2 degree. So the total degree, addition of both variable, addition of the degree power of both variable. So here total power is 3. So degree is 3 of this term. So each term of a differential equation, the total power of variable in a term are equal in each term is known as a homogeneous differential equation. So this is the basic definition of a homogeneous differential equation. So now this is, I want to check that this differential equation is non-exact. So if this given differential equation this given differential equation is non-exact, then this is not verify. This is verify the condition del m over del y is not equal del n over del x. This is non-exact condition. If any differential equation verify this condition, then given differential equation of first order and first degree is known as a non-exact differential equation. So now in our question here, m is given here x cube plus y cube. This is the coefficient of dx. In a differential equation, the m is the coefficient of dx and n is the coefficient of dy. So here n is minus xy square. N is minus xy square. So now differentiating m with respect to y. So we get del m over del y. X as a constant here because we are doing here partial derivative. When we are doing partial derivative with respect to y, then other variable keeping constant. So here are only two variable x and y, but we are doing here differential with respect to y. So x keeping as a constant. So differential del over del y of x cube plus y cube. So this del over del y of x cube and plus del over del y of y cube. But x is a constant here. X is a constant. So derivative this 0 and here is 3y square. So del m over del y is 3y square. Next one is differentiating n with respect to x. So we get del n over del x equal to del over del x of minus xy square. So here y as a constant, because we are doing here differential with respect to x, so partially, so other variables keeping constant, so other variable in this function is y, so y as a constant, differential with respect to only x. So here minus y square del over del x of x, so this is minus y square. So now del m over del y is not equal to del n over del x. So given differential equation is not exact. So given homogeneous differential equation is not exact. So now we are making given differential equation exact. Okay, so the given differential equation we are making as a exact. So how we can make exact? How can we make a differential equation non-exact to exact differential equation? So here we are using some steps one by one to first of all be making this differential equation as a in exact, non-exact to exact converting. First of all, we making the given homogeneous differential equation to non-exact to exact differential equation. Then when we convert in exact, then we are applying the formula of an exact in the differential equation and we solving completely solution. Okay. So step 1 here. In step 1, integrating factor. We are taking an integrating factor. This is 1 upon mx plus ny. M multiply by x plus n multiply by y and 1 upon. So this is a function. Basically, this is a function of x and y, and this function we multiply to the each term in differential equation, and differential equation becomes an exact. Step 2. In step 1, we are considering an integrating factor or integrating function, that is 1 upon mx plus ny. Okay, this is the formula for integrating factor for only homogeneous differential equation. For only homogeneous differential equation, integrating factor. Okay. Now step 2, multiplying by this integrating factor to given differential equation in each term. Then differential equation is an exact 100%. Now the homogeneous differential equation convert in exact when we apply by this integrating factor, and verify the condition and the homogeneous differential equation after multiplying the integrating factor. Verify the condition of an exact, this del m over del y equal to del n over del x. Then step 3 means, step 3 after multiplying by if, then solving the differential equation by the method of an exact. Okay. So here we are solving this problem. Problem 1 based on method 5. Based on method 5. Homogeneous differential equation. Our question is homogeneous differential equation. So here solving dy dx equal to x cube plus y cube upon xy square. This equation may be this type. Okay. But now in exact differential equation, our question is this type: x cube plus y cube into dx minus xy square into dy equal to 0. This equation 1. Now the general equation of an exact or non-exact differential equation, that is m dx plus n dy equal to 0. This is the equation 2. This is general equation. General equation of exact or non-exact. General differential equation of exact or non-exact differential equation. So this equation 2, this is 1. Comparing in 1 and 2. Comparing in 1 and 2 this. So now we get m is this and n is this. M equal to x cube plus y cube and n equal to minus xy square. So now differentiating with respect to y, differentiating with respect to y to m. Then we get del m over del y. So del over del y m, this equal to del over del y m x cube plus y cube. So this equal to x as a constant here. X as a constant here. Differentiating with respect to y. So x as a constant. X, keeping x as a constant. This is x. X as a constant. So now differential of this is 3y square. And n equal to minus xy square. So differentiating with n with respect to x, then del n over del x equal to minus del over del x of xy square. So this y as a constant, y as a constant. So now this equal to minus y square. So here we see that property of an exact, del m over del y is not equal to del n over del x. So the given homogeneous differential equation, homogeneous differential equation is not exact, is non-exact differential equation, exact differential equation. Okay, we have checked this one. Given question is not exact. So now we are showing here in del m over del y equal to del over del y x cube plus y cube. So here differentiating with respect to y, thus is 3y square, x is constant, x here is constant, x is constant here, and del n over del x of minus xy square, so that is y square. Here y is constant here. So what here we see that del m over del y is not equal del n over del x. So the given differential equation is not exact. Okay. Step 1, finding IF integrating factor here. The formula of integrating factor IF equal to 1 upon mx plus ny. So this equal to 1 upon mx cube plus y cube into x. This is m. From the given differential equation, this is the value m into x plus n. This is the value of n minus xy square, n into y. So we see that multiply by x की power 4 plus y cube into x minus x y cube. So this term is cancelled here. So we get here 1 upon x की power 4. So this is IF, this is integrating factor. Step 2, multiply by IF 1 upon x to the power 4 to the given differential equation, to the given each term of given differential equation. Then differential equation is an exact. Now step 1, I am solving here. Step 1, integrating factor IF. This is 1 upon mx plus ny. This is 1 upon mx cube plus y cube, n into x plus n minus xy square into y, mx plus ny. So this equal to 1 upon x to the power 4 and plus x cube by xy cube and minus xy cube. So this term is cancelled. So we get here only x to the power 4. This is integrating factor. Now step 2, multiply y if to given homogeneous differential equation. Okay, given homogeneous differential equation, multiply by IF integrating factor to given homogeneous differential equation in each term. Then we get. So now here x cube plus y cube into dx and minus xy square into dy equal to 0. So multiply y upon x की power 4 here in each term. So we write separately here x की power cube upon x to the power 4 into dx and plus y cube upon x की power 4 dx. Okay. So minus dx is this bracket. So minus here xy square upon x to the power 4 into dy. So here this cube cancel, 1 upon x and dx and 1 upon x plus y cube upon x की power 4 into dx and minus 1x is cancelled, y square upon x cube into dy equal to 0. Okay. So now here this equation 2 comparing 3. This equation is 3. Comparing this one to general equation m dx plus n dy equal to 0. Now m, after multiplying integrating factor, our equation is converted into this equation. So value of m is again, what is m? M is 1 upon x plus y cube upon x4. 1 upon x plus y cube upon x4. And now n is, what is n? N is minus y square upon x cube. N is minus y square upon x cube. So now we are checking here again, after multiplying integrating factor, our differential equation is not exact or not. Our differential equation is exact or not. Now check that given differential, that after multiply by if in given differential equation, equation is not exact, equation is exact or not, equation is exact or not, we are check out this condition. Okay, so m is this and n is this. Now del m over del y, this equal to del m over del y, this equal to differentiating, this is the only x as a constant, so 0, and plus differentiating with respect to y, 3y square upon x to the power 4, and del n over del x, this equal to here differentiating with respect to x, so y is constant, minus y square, del over del x of 1 upon x cube. So differential of this minus y square, differential of this minus 3 upon x to the power 4. So there is 3y square upon x to the power 4, del n over del x, this result, and del m over del y, this result. So here del m over del y equal to del n over del x. So the given differential equation is exact. So the differential equation is an exact after multiplying if. Now solution, how we can solve here? So solution, this step 3, solving differential equation by exact. So exact means integrating m dx by as a constant, plus integrating n dy not contain x, so here equal to constant c. So now we are taking m is this, m is, what is m here? 1 upon x plus y cube upon x4. M is 1 upon x plus y cube upon x4. So this is dy dx, and plus integrating n. In n is in n total, where is n? N is this. So n is total x and y mixed function here. So we are taking here 0 dy equal to c. So now integrating 1 upon x dx and plus y as a constant, y cube integration 1 upon x4 dx and plus 0 equal to c. So this is log x and plus y cube integration of this x to the minus 1 upon 3x cube and equal to c. So final answer, we are checking this equal to log x and plus y cube minus y cube upon 3x cube equal to c. So this is answer of differential equation. Okay, means a homogeneous differential equation is given, and there are two methods. We can solve homogeneous differential equation in the separator of homogeneous method, and we can solve with the help of non-exact method, because homogeneous differential equation always be non-exact. So we are taking here an integrating factor 1 upon mx plus ny and multiply by this integrating factor to the differential equation, and differential equation after multiplying by integrating factor, that it will be exact. Then the question solved with the help of exact method. So we are solving here. Okay. Now next problem. Next problem, also problem 2, on depend on homogeneous differential equation which is not exact. So here we can check here this is exact or not. So m equal to here x square and y. This m dx plus n dy. This equal to 0. This equation 1 and this equation 2. So m is this mx square y, and n is this minus x cube and minus y cube. Okay. So here del m over del y, this equal to differentiating with respect to y here. So we get only x square, and del n over del x. So this equal to minus 3x square and y 0. So del m over del y is not equal to del n over del x. So the given differential equation is not exact. Okay. We have checked. The given differential equation, differential equation is not exact. Is not exact. Okay, we have checked this. Now, step 1, we are making this homogeneous equation in exact. So step 1 is taking integrating factor, taking IF integrating factor. This is 1 upon mx plus ny. This is integrating factor. Okay. So this equal to 1 upon m. M is x square y into x, mx, plus n is minus x cube minus y cube into y. This is integrating factor. This is m, this is value of m, and this is value of n. So integrating factor. Now this equal to 1 upon x cube y and minus x cube y and minus y4, y to the power 4. So this term is cancelled. So here integrating factor is only IF. Integrating factor is minus 1 upon y to the power 4. We can take this y4 only. This is integrating factor. Okay. So now multiply step 2. Step 2, multiply y IF 1 upon y4 in each term of given homogeneous differential equation. Homogeneous differential equation. Okay. Then it becomes exact. So now our question is this x square y and plus minus x cube minus y cube into dy. So multiply here y full 1 upon y square. This is integrating factor. And this equal to here is dx. This equal to 0. So now multiplying by here x square upon y and dx minus x cube upon y square, x cube upon plus here I am writing here bracket, x cube upon y square minus y cube upon y square and dy equal to 0. So now here this is x square upon y dx minus plus minus x cube upon y square and minus here 1 y is cancelled, y square, y dy. So this equal to 0. Okay. X cube minus y cube, y4 है, there is y4 here, I am writing wrong, y4. So here is y4, here is y4 here. So here is y4 and here is also y4, here is y4. So here is y4, any 1 upon y here. There is 1 upon y only, okay, this is correct. There is y4 power, okay. This is y4. So this equation suppose A. So this is an exact. Here we multiply by integrating factor. This is IF, integrating factor. Then this differential equation is an exact. Again, I am solving, this is wrong. Correct. Multiply by an integrating factor to given differential equation. Here 1 upon y to the power 4. And here is function is x square y. I am writing here x square y dx and plus here minus x cube minus y cube and dy. So this equal to 0. Now multiply by this x square upon y4 into y and dx and plus minus x cube upon y4 and minus y cube upon y4 into dy equal to 0. X square y cube and dx plus minus x cube y4 and minus y cube y is cancelled here. So y is cancelled here. So we write here 1 upon y dy. Okay, this equal to 0. This is equation A. Now this is an exact differential equation. Check. We are checking here this is exact or not. So m equal to here. This is m dx and plus n dy. This equal to 0. Now m equal to, what is m here? M equal to is x square upon y cube, m equal to this, and n equal to this one minus x cube upon y4 minus x cube upon y4 and minus 1 upon y this one. So now this property should be verified. Del m over del y is equal to del n over del x. Here, so here differentiating with respect to m, with respect to y, x constant here. So del m over del y, this equal to here minus 3x square upon y4. Okay, differentiating 1 upon y cube here, y cube minus 3 upon y4. Now differentiating n with respect to x, so here x cube differentiating here minus 3x square upon y4 and differential of y is 0. So these both results are same. So here this implies that del m over del y equal to del n over del x. Okay. So given differential equation is an exact. Okay. So now we are integrating formula here. Integrating m dx, y as a constant, m dx and y as a constant here, plus integrating n dy not contain x, equal to c. So integrating m is x square upon y cube dx and plus integrating n not contain x. Not contain x means there is only 1 upon y. This term contain x. So here minus 1 upon y and dy equal to c. So here integrating this Y is a constant here. Y is a constant I am writing here. So 1 upon y cube integrating x square, x cube by 3 and minus log y and equal to c. So here answer is x cube upon 3y square minus log y equal to c. So this is the solution of the question. Okay. Now next problem 3 of homogeneous differential equation which is not exact. Okay. So here comparing this one m dx, this equation 1. Okay. Now this m dx and plus n dy, this equal to 0. This equation 2. Comparing 1 and 2. Comparing in 1 and 2. Then we get m equal to, m is y cube minus 3xy square and n equal to 2x square y minus xy square. Okay. So differentiating with respect to y to n. Differentiating n with respect to x. So here del m over del y, this equal to, differentiating with respect to y here, this is 3y square minus 3 to the 6xy. Differentiating with respect to y, x as a constant. So 3y square minus 6xy. Next here del n over del x, this equal to, differentiating with respect to x, y as a constant. So here is 4xy and minus y square. Okay. So del m over del y is not equal to here del n over del x. Okay. This formula is not verified. So given differential equation is not exact. So now here step 1. I am taking IF, integrating factor. So this is 1 upon mx plus ny. This integrating factor. So this equal to 1 upon mx. mx, what is m? M is given here y cube minus 3xy square. Y cube minus 3xy square. Y cube minus 3xy square here. Okay. So multiply by x and plus n. N is here 2x square y. 2x square y minus xy square minus xy square, and here is y. So now this 1 upon here y cube x minus 3x square y square, 3x square y square, multiply by x here and y here plus 2x square y square and minus x square y square minus xy cube here, xy cube. So this term is cancelled to this. So now here 1 upon only here minus 3x square y square and 2x. So here is minus x square y square. So this is IF integrating factor. So IF integrating factor is only 1 upon x square minus y square here. This is integrating factor. Next one, now step 2. Step 2 here. Multiply y IF integrating factor to given differential equation. To given differential equation. Differential equation. To given differential equation. Okay. Then we get here. First term is y cube. Here multiply 1 upon x square y square. This is IF. And here multiply by y cube minus 3xy square. Y cube minus 3xy square. And multiply by here dx. And plus n. N is 2x square y. 2x square y minus xy square. Xy square dy equal to 0. So this is an integrating factor. We multiply this differential equation by this factor, then this becomes an adject. So how becomes this adject? We are making here adject. Multiply by this here. Here by y cube upon x square y square. Okay. And dx minus 3xy square upon x square y square. Okay. So this is dx. And plus here 2x square y upon x square y square. And minus xy square upon x square y square. And dy equal to 0. So now here y square is cancelled. So we write here y upon only x square and dx this one. Minus x cancel and y square cancel. Minus 3 upon x and dx. And plus here next term this x square cancel and 1 y cancel. Plus 2 upon y and dy. Minus x cancel this x cancel. And here y square cancel. Okay. So here minus 1 upon x. xy क्यों है इधर? What is xy square upon x square y square. So only 1 upon x is dy here. Okay. So this equal to 0. Now these two terms are already variable separate here. So we apply here y dx upon x square. Y upon x square and dx. Next term minus 1 upon x dy. Minus 1 upon x dy. And plus here next term minus 3 upon x dx. Minus 3 upon x dx. X plus 2 upon y dy. Plus 2 upon y dy. Okay. This result. So these are variables separate. So I am making this result, integrating this, and integrating this. So this minus 3 integrating 1 upon x dx and plus 2 integrating 1 upon y dy. This equal to 0. This equal to constant and constant. So this here integrating is x square LCM and here is y dx and minus x dy. So this result. So integration of this result is minus taking common x dy and minus y dx upon x square. So this result and minus 3, this is the integration log x and plus 2 log y equal to here taking constant log c constant. Okay. So here this is the differentiation of y upon x we are writing. So this minus 3 log x and plus 2 log y and equal to log of c. So this is the differential cancel by integral. So here is y upon x and minus 3 log x and plus 2 log y and equal to log c. This is the complete solution of the question. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.